Welcome to the second episode of Under the Hood. So in the first episode, we talked about AI and how we develop AI features in Business Central. And short after we released this episode, we put out a small poll on social media where we asked you what you wanted to hear about in this series. We proposed several topics and the compiler won. So today with me I have Espen.
Thank you.
Who is the architect behind the EL compiler. But before we get into the details of the inner working of the EL compiler, let's start with a brief history. We had, before the EL compiler and VS Code, we had Seaside. And I'm sure some of you remember Seaside. So Espen, have you worked with Seaside?
Yes, I have actually worked a lot with Seaside. I have spent most of my time at Microsoft as a part of the NAV team. But actually the first thing I did in the NAV team was that I was sent over from the team I worked on, which was the old Microsoft Business Framework team, to help creating a prototype of the new client on top of Seaside, or what would become the 3-tier architecture. And we actually produced a video for Steve Ballmer, which it felt like a big thing back then. And
so we had like, back then we had like a 2-tier architecture.
Yes, yeah. The old Seaside were 2-tier. It was a client development environment, everything in one, talking directly to the database.
Yeah, so there was no, that's true. The client and the development environment were in the same same application.
Exactly.
Yeah.
And then when I joined the team, I worked a lot on the server side of it, and actually also the compilation from the old CL code into the C# code that was the foundation for the new 3-tier architecture.
So Seaside was written in C++, right?
Actually a mix of C and C++, because
C and C++.
Yes, okay. It was worse than C++.
Okay.
And it was it has its own memory manager and own error handling, not exception based as you could have done in C++. So it was a very slow process to develop new features.
So very costly to add new features.
Yes.
So there's no doubt that at some stage Seaside was due for a
modernization or replacement. Yes.
But it was hard because we talked about it many times.
Yes, we did. We have those talks over many years. The last one I remember was in 2014, I think. We were a team who was tasked with figuring out what should come next. And we actually, I recently looked at the old conclusions then. It was all about speedy delivery, modelized, best of class, development environment, marketplace. There was a lot of things which actually turned out to be what we have today.
So all the concepts
it was a nice vision document back then.
Yeah.
But we have no plans of how we would proceed. It was the vision we actually did that year.
And it was also difficult because we have, first of all, our own code base is pretty big, and rewriting it and to a new language would be like tremendous effort.
Yes.
And also there's a lot of code out there. A lot of partners have millions and millions of lines of code, and we didn't want to disrupt them, right?
Yeah. Exactly. So what we looked at the year after was I built a small prototype, and it was actually shown at Tech Days in 2015 by Tom Heisberg. And it was essentially a small WinForms app where we loaded in a TXT file from export I think the sales postcode unit. And you could make changes to it, and it instantly gave passing diagnostics in the UI. It was most of all a nice picture of what could be a compiler someday. It was pretty far from what we needed.
Okay. But then you had this brilliant idea how to transition from having these large code base, including our base app, and but also the partner code, how we could transition from that to a new model, a new development environment, right?
Yeah, and in the beginning it was, the brilliant idea come out of necessity, because we had, our base app is so big, and we knew that it would take years before we were actually able to compile it. So we had to figure out how we could start working with this, get feedback. So the idea was that because we have decided that our new language would be modularized, so we knew that we would introduce dependencies between modules, and we have already created a format for that, which were the reference symbol information that we store in the app files. And the idea was that we could just use Seaside to create a similar symbolic format, and based on the base app, but now we have what is needed for AEL to work on top.
So kind of wrapping it in something that would look like, so from the outside it would look like it was the new code, but underneath it was the old code, and then we could start working on top of that with the new tools, right?
Exactly, and that allowed us to ship early previews of it, and we did that for a couple of years. And the initial one was only we could create simple code units, simple tables, pages, and then we also introduced table extensions and page extensions for that. So you could already there, we wanted to promote the new model with...
So you could write extensions already, or partners could write extensions. Yes. We also had a few first-party extensions, I believe. Yes. But our own code base didn't compile yet with the new tool.
No, and it took a couple of years. In 2019, in Wave 2, we shipped the first AEL compiler without the preview mark on it. And that at that time, we could compile all objects, we could do most, but we haven't converted our own base app yet. That took another year because we have had an insane amount of dependencies on how we did stuff internally. So it took another year before we could actually ship completely without.
So let's go really under the hood now. So when you started working on this new compiler, we needed an architecture.
Yes. And I think 2015 was the perfect storm for this, because C# the year before has actually released Roslyn. They have gone through some of the similar thought processes, even though they were at a better starting point than us.
So Roslyn was the new C# compiler, like a totally new rewritten compiler, actually, yes. Wasn't it?
Exactly. Yeah. Actually, the original C# compiler was written in, I guess, C++ or something like that.
Just like us.
Just like us. And they moved to C#, so it's basically compiling yourself approach. But that was a smaller part of it. The more important part was that they realized that they already they had one compiler for a command line and almost a similar compiler that were used inside Visual Studio to provide IntelliSense and all that. And they merged that into one, or a componentized solution where they could use the compiler as a service. So the same compiler, the same base part of the compiler that serves the command line compilation is also the one that constantly runs in the background and provides IntelliSense, cross-references, all the things we like to have in a modern environment.
And that's the Roslyn architecture.
Yes, that was the architecture we also, took a great deal of inspiration from, because,
So you looked at it and said, okay, that's a good idea.
That's a really good idea. We want to have that as well. Yes.
Let's do some. So just to be clear, we didn't reuse any of the code, did we?
Not
such.
Not.
We just used the architecture.
It's not Roslyn, but we have moved a lot of the concepts out of the Roslyn code base, because we're not a true .NET language.
Right.
So we couldn't just build. Roslyn already contains VB.NET, C# and also F# based on the same core libraries, but they are all true .NET languages, and we are not. So we pulled out the stuff we needed, augmented it, and built a lot more on top. In some sense, because we have way more concepts than C#, for instance. So in some sense, we are more complicated because we have, 7, 8 top-level symbols where C# have class, enum, struct.
Yeah, so we have pages, tables.
Exactly. So we have a lot more differences in our version.
So you talked about the perfect storm. By that you meant there was a Roslyn compiler
and also Visual Studio Code. When we pitched the original one in 2015, Visual Studio Code was in version 0.6 and was very immature but very promising. And we decided to bet on that, and it fit also very nicely with the Roslyn architecture we used. And before that, we actually, if we have started out coding the year before, we wouldn't have probably done it right. But this time, we have these two great components to lean against, and it's a really, really nice architecture.
Just to be clear, on one hand there's the Roslyn compiler, the Roslyn architecture,
Yes.
and but it has nothing to do actually with Visual Studio Code. It's
No.
just an independent architecture.
Yes.
Actually, when you run, when you compile, say from the command line, it goes through this pipeline, this architecture,
Yes.
and it's totally independent of Visual Studio Code, right?
Exactly.
But you call it the perfect storm because on one hand we had this great development environment which Visual Studio Code is, and then the Roslyn architecture. So we took inspiration from one and built it into the other, and then that's how the new toolset was born.
Yes. And we knew that Visual Studio Code was an early beta at that point in time, but we also realized that we could easily repurpose the compiler to another environment if we had to. But it turned out that best decision ever to bet on Visual Studio Code, because it's have turned out to be the gift that keeps on giving for us. We get new features every year or every month, and we can easily adapt to them. So
yeah, there's a lot of advantages of being in Visual Studio Code.
there's a lot of
leverage
advantages.
all the things that it offers.
And it allows us to focus on what is important for us, which is our language, the concepts that we need for the platform, rather than inventing a lot of UI for showing IntelliSense and all that.
Things like that. Yeah, we get most of that for free. Right? So you mentioned that we have a language service as part of it, which is kind of what the Roslyn architecture also has. So how is that a good thing? Why do we need a language service?
We need a language service because modern developers actually expect to be able to get IntelliSense, get information about the symbols in the editor. So whenever you type, we need the compiler to run instantly
Constantly.
in the background.
That's what the language service does.
Yes, exactly. So it has the set of all files, and it constantly provides a new compilation that
Even partial compilations, right?
even partial
Because
compilation.
typically when you type, by definition, you are, it's like you've written half of the code or less, and then typically doesn't compile. Most of the time, when you're in the compiler, what you have written in your editor does not compile.
Exactly.
So it requires the background compilation to be able to do some partial compilation.
Yes,
if you want
and,
to do IntelliSense and things like
and be
that.
good at recovery. That's actually one of the harder parts, because it's textbook to create a compiler that has a perfect source,
Mhm.
but having a source where you are typing something in the middle, but you would still like to have IntelliSense for what comes after, means that you need to do recovery. And another important aspect of that is also that when you only make small changes, you don't want to repass everything. You want to reuse as much as possible to be memory efficient in the background compilation.
Yeah, so it's you have good performance and
Yes.
a good experience as a developer. Yeah.
And that's actually one of the places where we really benefited from what we got from Roslyn, because it's helped us be efficient there. And the language service is also an integral part of Visual Studio Code and how they envision that you extend Visual Studio Code with other languages.
So that's the architecture they recommend if you want to implement a new language.
Yes, and they actually invented what is called the Language Service Protocol exactly for this. And it's a description of the communication between an editor and between languages. And the idea is that as long as you adhere to the LSP, you can replace languages or you can replace editors.
That's actually a standard, an open source protocol, isn't it?
It is an open source protocol, and it's very efficient, and They often come with new additions to it that we can then uptake, and we can add support for that in our language server. So we suddenly support new features invented in Visual Studio Code.
So when we started modernizing the whole development environment and starting, kind of revamping the language, we could have chosen an existing language. Like we could have chosen, TypeScript, JavaScript, or even Python. Then we wouldn't have had to write a compiler, because there are compilers out there. So why didn't we do that?
Oh, there's a couple of reasons. One of the reasons is that we need a sandbox language. Since we are running third-party code on our servers, we need something that we could control.
So for security reasons, for example.
Yes. So it's not an option for us to go directly to .NET. We need to somehow use the language as a barrier, or having a trusted runtime for it. That was one of the reasons. The other reason is that we could go through the process of converting our own base app to any language, potentially.
That's still a lot of work.
Still a lot of work, and the result may not be as easy to work with, and actually would end up not having the same connection between data and metadata that we have. We have which is rather unique in my opinion. You can stand on a table field and you can get cross-references for all the places where it's used.
This is a language that's been written for ERP and for Business Central.
Exactly. But the most important part of this was that our entire partner channel have invested in this language. So we actually have gone through great work to preserve as much of their IP as possible in the process. We know that from time to time, yes, we have asked our channel to make changes. We don't like it, and we know that they definitely don't like it.
We do have breaking changes, but
we do have.
But we do what we can to preserve. If you look at the whole history of Nav and Business Central, we've went through a lot of efforts to preserve this code base throughout all these years. Maybe that could be the topic of another Under the Hood talks, actually.
Yeah, it is actually something we have spent a lot of time on over the years. Yes.
So you said that we're not AL is not a true .NET language. However, the AL compiler is not exactly a compiler. We're not compiling in the pure sense of the word, meaning we're not producing executable bits and bytes and artifacts that can be executed directly on the operating system. It's more of a transpiler, right? We are converting AL to C#.
Yes.
Is that a good idea?
Yes, I think for us it is. This is what we did originally in Seaside.
So Seaside did the same thing.
Yes, Seaside did the same thing. And when we started out, we couldn't also take upon the task to compile directly to IL. It's hard. It would be harder for us to verify. It would be harder for us to debug. So we chose that if we just did what Seaside did, the runtime would actually work even though we had a new compiler.
So what happened when I have a snippet of code, the compiler takes it, and the EL compiler takes it, and actually generates some C# code that basically does the same thing, but in C#. And then we compile the C# code after that to an actual execute, using the regular C# compiler, right?
Yes, that's exactly what we're doing.
Okay.
And then we have some additional metadata we actually put in, most cases XML, and also store that in the runtime or in the database. So this is what we use for execution.
So back to VS Code and back to the paradigm shift from Seaside to AL. There was another. So we went from Seaside to VS Code. That was one paradigm shift, but there was another pretty significant paradigm shift that we went through at that stage. We went from a repository-based source artifacts to a text file-based artifact. So before in Seaside, when the code you wrote was actually stored in the database, right? And now with Visual Studio Code and with the L compiler, the code is actually saved in text file. like many other languages like C# and JavaScript and so forth. So was that a good thing or?
Yeah, in my opinion, it was definitely a good thing. Early on in my tenure in NAV, I worked on modernizing the build pipeline for the application, and me and a colleague was tasked to work with that. And at that point in time, all the sources were exported from Seaside into the TXT file, and then they had to use a small VB application that using automation on top of Seaside to create database, import objects, compile all objects, which was horrible to automate. So the first thing we actually did was to just turn Seaside give Seaside a command line so you could actually compile from the command line. It was not pretty, but it was better than what it was. And from that point on, I just dreamt about fixing this for real because it was not nice to work with it.
Well, and there's a lot of advantages of having the source code in text because there's a lot of tools out there which like source control tool like Git or searching. If you want to search through the code, right? There's a lot of search tools and that.
Yes, and when you work, and when you work with repositories like Git or DevOps, we also now have syntax highlighter in there, so you can actually better inspect your source code. So there's a lot of benefits from that. And also, there was sort of a parallel effort to our cloud endeavor at that point in time, but it also turns out that having the requirement to talk directly to a database in the cloud is a very bad idea. So it matches that as well.
So another thing that happened when we moved from Seaside to Visual Studio Code is that we had some designers in Seaside, and these designers disappeared. We went to again a fully text-based approach where instead of describing things through these designers, you would have to describe them in the text file directly in the file where you had your code, right?
Yeah.
And we got a lot of feedback on this. People are still asking about it. Then you had another great idea about that.
Yes, the last couple of years I have focused a lot on trying to figure out how we can make our biggest API, which is our base app, more visible, better discoverable, navigable. And one of the ideas I wanted to explore was how if we somehow could use the WebView feature in Visual Studio Code in combination with our language server to actually put some UI on top of our application object.
So just to explain a little bit, the WebView feature in Visual Studio Code, it's actually a page that you can have. Like normally in Visual Studio Code, when you open a file, it's typically a text file that will show the content of the file. Yeah. But Visual Studio Code has this feature where you can actually have a page, which is in a sense a browser. Yeah. Right? And you can display HTML in it, so you can display pretty advanced UI in it.
Yeah.
And this page can communicate with other regular text pages. Like, for example, you can have, a good example is, like I think many people are familiar with, is if you open a README file, you can see the markup language in the text file, and you can see the preview of it
yes.
In the actual formatted way.
They actually Visual Studio Code have two concepts. They have one which is a WebView disconnected from source, and then they have the custom design, I think, WebView. And what we shipped first was actually AL Explorer and AL Home. They are built on just being a WebView disconnected from source. But the AL Explorer is using actually the same grid as our analysis view to show all the objects, and they get the information from the running compilation. So it's not statically when you go and edit something in a file somewhere, it also shows up because it's running.
So that's a page in the AL Explorer. That's a page in Visual Studio Code that allows you to actually navigate your code, and you can do some. We'll put a link in the comments on the documentation of the AL Explorer. Right?
And also we added AL Home, which is a news feed for developers. Business Central AL developers, where we with that suddenly have a way of communicating directly with our developers, which is a nice new feature. But also, and I know you remember that because we were on the same session in Directions EMEA in Hamburg, where I showed up of a couple of designers, table designer, page designers. They are built on the other model, the custom designer model, which actually is a visualization of the source code, which means that if you make changes through the designer, it updates the source.
So that's the old designers.
That was actually
in a new Visual Studio Code environment, right? But that's still a prototype, right?
Still a prototype. I would love us to productize them, but again, we need to prioritize. So, but it shows it can be done with this functionality.
So we have some ideas and how to maybe revive these designers at some stage, right? But it's still at the prototype level.
Yes.
So one last thing, we also have a lot of people asking us to expose the compiler as an API. They would like to be able to use it to do all sorts of things, and some people are actually doing it already in a kind of non-supported way. Is that something we are going to do?
From the beginning, when we started creating the new compiler, based on the Roslyn model, it's envisioned as a service. We haven't officially opened up for for external use, means that we haven't documented it, but we know there's a lot of partners out there that are actually...
We're not preventing it.
No, we're not preventing it.
We're not just supporting it, and we reserve ourselves the right to change it at any time.
And we actually, we try not to break anything. Also here, even though we haven't officially supported, we actually we know that it's used, and it's used for the benefit of our community, which is great. And I love
we don't prevent it.
And I love to see all the things which are actually...
The people are doing pretty cool things with it, right?
Yes, exactly. And there's, already incredibly many AL-related extensions in the Visual Studio Code marketplace, which is amazing to see the ideas and creativity that our partner John is actually adding also in the development area.
Okay, so if maybe to conclude, I would ask you if if I'm a new developer, if I'm new to AL, new to Business Central, what would you recommend? Where do I start? How do I get started with developing extensions for Business Central?
Yeah, there's of course our own documentation on MS Learn, which is both a combination of reference documentation, but also getting started documentation. And then there's our launch event videos, and which also talks about all the new features and sometimes also a little bit broader. And actually our partner channel also here are doing an amazing work. We have many partners blogging or creating videos around development.
So lots of resources out there.
There's lots of resources which are, really great resources. And it's also really great to see how many actually want to contribute and make this an even better community.
It's a really great community we have out there. Thank you for supporting us.
Yes, thank you very much.
All right, thank you, Espen.
Yes, thank you.
I hope you enjoyed this talk about the inner workings of the AL compiler. Let us know in the comments. Next time we'll try to answer the question, how many users can Business Central handle in the cloud? So stay tuned, and thank you for watching.